1. AI, artificial intelligence. Machines designed to mimic human intelligence by performing tasks like reasoning, learning, and problem-solving. 2. Machine learning, ML, a method that allows computers to learn from data and improve performance over time without being explicitly programmed. 3. Deep learning, a powerful branch of machine learning that uses layered neural networks to recognize complex patterns in large data sets. 4. Model, a trained algorithm that uses patterns learned from data to make predictions or decisions on new inputs. 5. Training data, the data set used to teach an AI model how to recognize patterns and produce accurate results. 6. Inference, the process where a trained AI model applies what it learned to make predictions on new, unseen data. 7. Bias, a flaw in an AI model that leads to unfair or skewed results, often caused by imbalanced or unrepresentative training data. 8. Overfitting, when a model memorizes training data too closely and fails to generalize accurately to new real-world inputs. 9. Underfitting, when a model is too simple to capture meaningful patterns, resulting in poor performance on both training and new data. 10. Black box model, an AI system whose internal decision-making process is too complex or opaque to be easily understood or explained. Neural networks and AMP architecture. Neural network, a computing system made up of interconnected nodes that process information in a way inspired by the human brain. 12. Node, an individual processing unit within a neural network that receives inputs, processes them, and passes the result forward. 13. Layer, a collection of nodes in a neural network, each responsible for extracting a specific level of features from the data. 14. Input layer, the first layer of a neural network where raw data enters the model to begin the processing pipeline. 15. Hidden layer, the middle layers of a neural network where most of the feature extraction and computation takes place. 16. Output layer, the final layer of a neural network that produces the model's prediction, classification, or decision. 17. Activation function, a mathematical function that determines whether a node fires or not, helping the model learn nonlinear patterns. 18. Weights, numerical values inside a neural network that control how much influence one node has on the next during processing. 19. Backpropagation, a training method where prediction errors are passed backward through the network to update weights and improve accuracy. 20. Gradient descent, an optimization algorithm that minimizes model errors by incrementally adjusting parameters in the direction of lowest loss. Natural language ANAMP, chatbots. 21. NLP, natural language processing, a branch of AI focused on enabling machines to understand, interpret, and generate human language. 22. Tokenization, the process of breaking text into smaller units, such as words or subwords, so an AI model can process them. 23. Prompt injection, a technique used to manipulate AI systems by embedding hidden or malicious instructions within user-provided inputs. 24. Chatbot, a software application that simulates human conversation, typically powered by natural language processing or a large language model. 25. LLM, large language model, a massive AI model trained on enormous amounts of text data to understand and generate human language at scale. 26. Context window, the maximum amount of text an LLM can actively process and reference at one time during a conversation. 27. Embedding. The process of converting words or data points into numerical vectors so AI models can measure relationships between them. 28. Hallucination. When an AI model generates information that sounds plausible but is factually incorrect or entirely fabricated. 29. Fine-tuning. Retraining a pre-existing AI model on new specialized data to improve its performance for a specific task or domain. 30. Zero-shot learning. A model's ability to make reasonable predictions on tasks it was never explicitly trained on. AI-specific security threats. Adversarial example. A carefully crafted input with subtle modifications designed to fool an AI model into making an incorrect prediction. 32. Data poisoning. Deliberately corrupting a model's training data to cause it to learn incorrect, biased, or harmful behaviors. 33. Model inversion. An attack where an adversary reconstructs private training data by repeatedly querying a model's prediction outputs. 34. Membership inference attack. An attack that attempts to determine whether a specific data record was used in training a target AI model. 35. Transferability attack. An adversarial attack originally crafted against one AI model that also succeeds in fooling other models it was not designed for. 36. Model stealing. An attack where an adversary reverse engineers a proprietary AI model by studying its outputs to build a functional copy. 37. Privacy leakage. When an AI model inadvertently exposes sensitive or personally identifiable information from its training data. 38. Shadow model. A replica AI model built by an attacker to study and develop exploits against the real target model. 39. Backdoor attack. A hidden vulnerability intentionally planted in an AI model that causes malicious behavior when a specific trigger is present. 40. Evasion attack. An attack where inputs are carefully crafted to bypass or fool AI-powered detection systems without being flagged. Defense techniques. 41. Explainability. XI. The ability to interpret and communicate how an AI model arrives at a specific prediction or decision. 42. Differential privacy. A technique that adds controlled mathematical noise to datasets so individual records remain private during AI training. 43. Federated learning. A distributed training approach where AI models learn from data on local devices without that data ever leaving the device. 44. Watermarking AI models. Embedding hidden identifiers into an AI model's behavior or weights to prove ownership and detect theft. 45. Red teaming AI. Proactively simulating adversarial attacks against AI systems to uncover vulnerabilities before real attackers can exploit them. 46. Secure enclave. A protected region of hardware that isolates and secures sensitive data and computations during active processing. 47. Threat modeling for AI. A structured process of identifying, analyzing, and prioritizing potential security risks specific to AI systems. 48. Model monitoring. Continuously tracking an AI model's performance in production to detect drift, degradation, or unexpected behavior. 49. Audit trail. A detailed log of an AI system's decisions, inputs, and outputs maintained for accountability, investigation, and compliance. 50. Model retraining. Periodically updating an AI model with new data to preserve accuracy and adapt to changing real-world conditions. Governance, compliance, and AMP, ethics, Entre 1, AI governance, the policies, oversight structures, and accountability frameworks that guide how AI systems are built and used responsibly. 52. AI ethics, a set of principles designed to ensure AI systems are developed and deployed in ways that are fair, transparent, and beneficial. 53. AI risk management, the practice of identifying, evaluating, and reducing the potential harms and failures associated with AI systems. 54. Bias auditing, a review process that systematically examines an AI system for discriminatory patterns or inequitable outcomes across groups. 55. Model card, a short standardized document that describes what an AI model does, how it was trained, its intended use, and its known limitations. 56. Data sheet for datasets, documentation that details the composition, collection process, intended use, and limitations of a training dataset. 57. Transparency, the principle that organizations should be open and honest about how their AI systems work and how decisions are made. 58. Fairness, the goal of ensuring AI systems produce equitable outcomes and do not systematically disadvantage any individual or group. 59. Accountability, the principle that developers, deployers, and organizations are responsible for the outcomes their AI systems produce. 60. Algorithmic accountability, the practice of ensuring AI systems can be audited, challenged, and held responsible for the decisions they make. AI in cybersecurity. 1. AI-based malware detection, using machine learning to identify malicious software based on behavioral patterns rather than known static signatures. 62. Behavioral analysis, continuously monitoring how users, devices, and applications behave over time to detect anomalies that signal threats. 63. Threat intelligence automation, leveraging AI to automatically collect, process, and act on threat data at a speed no human analyst could match. 64. CM, Security Information and Event Management, a platform that aggregates and analyzes security event data from across an organization to detect threats in real time. 65. SOAR, Security Orchestration, Automation, and Response, technology that automates and coordinates security workflows to accelerate detection, investigation, and response. 66. Phishing detection with AI, using machine learning algorithms to analyze emails and links and identify phishing attempts before they reach the end user. 67. Anomaly detection, an AI-powered technique that identifies unusual patterns in data or behavior that deviate from an established baseline. 68. Deception technology, security tools that deploy fake assets and environments to lure attackers, gather intelligence, and expose their techniques. 69. Insider threat detection, using AI to analyze patterns of behavior within an organization that may indicate malicious or negligent insider activity. 70. Fraud detection AI, machine learning systems trained to identify suspicious financial transactions or account behavior that may indicate fraud. Development and AMP deployment. 71. Model deployment, the process of integrating a trained AI model into a production system where it can begin serving real users and use cases. 72. Inference API, a programming interface that allows external applications to send data to a deployed AI model and receive predictions in return. 73. Containerization. Packaging an AI application and all its dependencies together so it can run consistently across different environments and platforms. 74. ML Ops, a set of practices that applies DevOps principles to machine learning, automating the full lifecycle from development to deployment to monitoring. 75. Versioning, tracking changes made to AI models over time so teams can reproduce past results, roll back updates, and maintain auditability. 76. CI/CD for ML, continuous integration and delivery pipelines adapted for machine learning workflows to automate testing and deployment of models. 77. A/B testing, a method of comparing two versions of an AI model or feature with real users to determine which one performs better. 78. Latency, the time it takes for an AI model to receive a request and return a response, directly impacting the user experience. 79. Throughput, the number of requests an AI system can successfully process within a defined period of time. 80. Failover, a redundancy mechanism that automatically switches to a backup system when the primary AI service experiences a failure. Business ANAMP, Industry 81, Model as a Service. MAAS, a delivery model where organizations access pre-built AI capabilities through a cloud API without building or hosting models themselves. 82. AI vendor risk, the security, compliance, and operational risks introduced when an organization relies on third-party AI tools or platforms. 83. Data residency, legal and regulatory requirements that specify which geographic location an organization's data must be physically stored in. 84. Data sovereignty, the principle that data is subject to the laws and regulations of the country in which it was collected or is stored. 85. AI policy, an organization's internal rules that define how AI tools may be used, what data they can access, and who is accountable. 86. Third-party risk management, the ongoing process of assessing and managing the security and compliance risks posed by external AI vendors and service providers. 87. Ethical AI sourcing, ensuring that the data, tools, and AI systems an organization uses were obtained and are operated in a responsible and lawful manner. 88. AI ROI, return on investment, a measure of the financial value and business benefit an organization gains from deploying a specific AI solution. 89. RegTech, regulatory technology often powered by AI that helps organizations meet compliance requirements more efficiently and accurately. 90. GRC, governance, risk, and compliance, an integrated framework that incorporates AI-related governance, risk management, and regulatory compliance into organizational strategy. Emerging concepts. 91. AGI, artificial general intelligence, a theoretical form of AI that can perform any intellectual task a human can, flexibly across all domains without task-specific training. 92. ASI, artificial superintelligence, a hypothetical AI system that surpasses human intelligence across every domain, including creativity, reasoning, and scientific discovery. 93. Synthetic data, artificially generated data that mimics the statistical properties of real data used to train AI models while protecting privacy. 94. Digital twin. A virtual replica of a real-world system or environment used to simulate scenarios, run tests, and analyze outcomes safely. 95. Swarm intelligence. AI behavior modeled after how decentralized groups, like ants or birds, collectively solve complex problems through simple local interactions. 96. Generative AI. AI systems capable of producing new original content, including text, images, audio, and video, based on patterns learned from training data. 97. Prompt engineering. The practice of crafting precise and effective inputs for AI language models to consistently produce accurate and useful outputs. 98. Multimodal AI. AI systems capable of processing and reasoning across multiple input types simultaneously, such as text, images, audio, and video. 99. AI alignment. The challenge of designing AI systems whose goals, values, and behaviors remain consistently aligned with human intentions and ethics. 100. AI safety. The field dedicated to ensuring advanced AI systems remain beneficial, predictable, and free from catastrophic or unintended consequences.